view. So we will proceed further. Now we will learn about the algebra of linear transformations. So this is algebra of linear transformations. So we will take up the first result. We shall do it in the form of a theorem. Actually, it's a short exercise and an easy exercise. So let's write it in the form of a theorem. जिस तरह से notes पे भी लिखा हुआ है. So let's state it like this. Let V and W be vector spaces. Let V and W be vector spaces over a field F over F, and let T be a let T1 and T2 be the linear transformations. Be the linear transformations from V to W. Then T1 plus T2 is also a linear transformation from V to W, and alpha times T1 is a linear transformation, or let's write alpha T is a linear transformation from V to W for any linear transformation T from V into W. तो इसमें हमें क्या करना होगा? So actually we have to show that if we have any two linear transformations from V into W, then their sum is again a linear transformation. And scalar times a linear transformation is always a linear transformation. So we have to prove these two things. The sum of linear transformations is a linear transformation, and scalar times of a linear transformation is also a linear transformation between the same vector spaces. Now the solution for it. So first let T1 from V into W and T2 from V into W be two linear transformations. Suppose these are two linear transformations. Then what we have to show, we have to show that T1 plus T2 is a linear transformation. To show T1 plus T2 is also a linear transformation. तो इसको प्रूव करने के लिए पहले हम इस चीज को लिखेंगे, how what we mean by saying that T1 is a linear transformation. Now since T1 and T2 are linear transformations, since T1 and T2 are linear transformations, thus we have T1 of suppose this alpha 1 V1 plus V2 is equal to alpha 1 T1 of V1 plus T1 of V2. ठीक है, and इसी तरह से T2 Suppose let's choose some different scalar or not necessarily different. So let's be more general. Alpha 1, alpha 2 may be equal or they may be different. And now for any vectors v1 and v2, this should be equal to alpha 2 t2 of v1 plus t2 of v2. And this thing should happen for all alpha 1, alpha 2 belonging to the scalar field F and v1, v2 belonging to the vector space V. So therefore, this is what we mean by saying that T1 and T2 are linear transformations. We must have T1 alpha 1 V1 plus V2 should be equal to alpha 1 T1 of V1 plus T1 of V2. And similarly, T2 is a linear transformation. So therefore, for any scalar alpha 2 and any vectors V1 and V2, we must have T2 of alpha 2 V2, V1 plus V2 is equal to alpha 2 T2 of V1 plus T2 of V2. Now we have to prove a similar condition for T1 plus T2. So that means we will need to choose, we will have to prove that for any scalar alpha in the vector field, in the scalar field F, and for any vectors V1 and V2, we must have T1 plus T2 of alpha V1 plus V2 is equal to this linear thing. So let us now do the same thing. Now let alpha belong to F and let us choose u comma v belonging to v. Then what about t1 plus t2 of alpha u plus v? Now let us see what is this thing. Now first we know by the addition of, actually we should have defined how we define the addition of these linear transformations. The addition is defined in this way. That's actually natural thing to do it. So it is t1 plus t2 v. This is defined as T1 of V plus T2 of V. Under this function, under this definition of the sum of linear transformations, this T1 plus T2 is again a linear transformation. So now, by definition of this T1 plus T2, this can be written as, this is T1 of alpha U plus V plus T2 of alpha U plus V. Now T1 is a linear transformation, so the first can be written as alpha T1 of U plus T1 of V. So this is the first one here. Then the second one is alpha T2 of U plus T2 of V. So this is the second equation here. We have to show that it is alpha times T1 plus T2. So now taking this term and this term, तो इन दोनों में से हम alpha common निकाल सकते हैं. This alpha times T1U plus T2U, then plus, then T1 of V plus T2 of V. Now again, this is equal to, now alpha times, now again by definition, this can be written as, this is T1 of plus T2 of U, because we have defined this T1 plus T2 of V is equal to T1 of V plus T2 of V. So here we are doing the reverse thing. T1 of V plus T2 of V is equal to T1 plus T2 of U. So similarly then plus, this is T1 plus T2 of V. So therefore we have shown that T1 plus T2 alpha U plus V is alpha times T1 plus T2 of U plus T1 plus T2 of V. So thus T1 plus T2 is a linear transformation. ठीक है, समझ में आया आपको ये?
Yes, sir.
Yes, sir.
Okay, now the second part is to show alpha t is a linear transformation to show alpha t is a linear transformation where alpha is any scalar and t from V into W is a linear transformation. So actually we have to show that if T is any linear transformation from V into W, then alpha T is also a linear transformation from V into W. तो यहाँ पे अगर हम ऐड करना चाहेंगे to show that alpha T from V into W is a linear transformation where alpha belongs to F and T from V into W is a linear transformation. Now since T from V into W is a linear transformation, thus T of something like AU plus V, this should be equal to A times T of U plus T of V for all A belonging to the scalar field and UV belonging to V. So now alpha T time of, let's choose the same AU plus V and let's see what is this equal to. Now this is equal to so this is equal to what? Now this is defined as alpha T of AU plus V. Now T is this linear, so this alpha AT of U plus T of V. So now multiplying it, so this is equal to alpha A T of U plus alpha T of V. So here we are using the distributive property in the vector space W. Now this is equal to, this can be written as A times alpha T of U plus alpha T of V. So therefore we have shown that alpha T of AU plus V is equal to A times alpha T of U plus alpha T of V. So thus alpha times T is a linear transformation. ठीक है ये भी?
Yes, sir.
Okay, now the thing next we are going to do is what we mean by doing the previous exercise. Now suppose let V and W be any two vector spaces. Let these be any two vector spaces. Then the set of all linear transformations. The set of all linear transformations from V to W is denoted by, this is just a notation, is denoted by L of VW. So this is linear transformation from V into W. That is, this is the set of all linear transformations from V into W. So that is this L of VW. This is equal to the set, such set containing T such that T from V into W such that T from V into W is a linear transformation. So that is the collection of all linear transformations that can be defined between two vector spaces V and W. That collection of all linear transformation is denoted by L of VW, V comma W. ठीक है, ये समझ में आया आपको? What is this L of VW? This is just a collection of all linear transformations between these two vector space. तो जो भी linear transformations हम दो vector space के बीच में define कर सकते हैं, then the collection of all those linear transformation is denoted by the set L of VW. चलिए इससे पहले अगर हम इस तरह से कुछ करना चाहेंगे, which is not actually related to the linear transformation, suppose we do something like this. अगर हमारे पास होगी, what is the number of all functions from, what is the functions from x into y? तो हम कितनी functions define, not the linear transformation, हम x और y के बीच में कितनी functions define कर सकते हैं? पता है किसी को? ओके पहले
m power m.
M raised power M.
What-
B raised power cardinality of X.
First, what is number of relations from x into y, assuming that cardinality of x is finite and cardinality of y is also finite. Now, first, what is number of relations from x into y? What is the relation? आपको relation पता है? What is the relation? Relation from x into y. What is that?
2 power mn.
It's a subset of x cross y. ठीक है?
Yes, cross yes.
The relation is a
Cardinal.
subset of x cross y. Now, how many subsets of x cross y are there?
2 power cardinality of X and cardinality of Y.
So it is
Sort of.
2 power cardinality of x into cardinality of y. This is the number of relation. This is the number of relations from x into y. Now next is, now all the relations may not be functions. So now let us restrict these relations to functions only. So now what is number of functions? From x into y. This is equal to, this is the cardinality of y power cardinality of x. ठीक है?
Cardinality of X.
तो इसी तरह से आप देख सकते हैं what is number of one functions. You can also find out what is the number of owned functions and so on. लेकिन हमें वो चीज़ नहीं चाहिए. और अब हमारे पास इतने सारे रिलेशंस है और उन रिलेशंस में से इतनी सारी फंक्शंस है, तो उनमें से फिर कुछ फंक्शंस वन वन होंगी, कुछ ऑन टू होंगी, और इन्हीं फंक्शंस में से जो यहाँ पे सेट ऑफ कलेक्शन ऑफ ऑल फंक्शंस है फ्रॉम बिटवीन टू एक्स एंड वाई, तो इसी तरह से अगर हम सारी फंक्शंस लेंगे between two vector spaces v and w, if we take all the functions from v into w, then the number of functions will be cardinality of w power cardinality.
Cardinality of v.
लेकिन इन सारी फंक्शंस में कुछ ऐसी फंक्शंस भी होंगी which are linear functions. तो अब हमें देखना है जो linear functions होंगी, that collection is now written here. This L of vu denotes only those functions from v into w which are the linear maps. तो बाकी हमें इसे exclude करनी है. So therefore the set of all functions from v into w shall be denoted by L of vu, which is read as the set of linear functions from v into w. Now we will take up a result about this L of VW. Let's write it in a kind of in a form of a theorem. Let V and W be two vector spaces. Be two vector spaces over the same field F. Over the same field F. Then L of VW is a vector space. So the collection of all linear transformations between these two vector spaces is a vector space over the same field F. Is a vector space over the field F with addition and scalar multiplication and scalar multiplication defined as और एडिशन और स्केलर मल्टीप्लिकेशन हम इस तरह से डिफाइन करेंगे डिफाइंड एज t1 plus t2 of v it is equal to t1 of v plus t2 of v. This is the addition of the mappings in linear transformation is L of VW under which this forms an additive abelian group and alpha times t of v is equal to alpha t of v respectively. Now we have this collection of all linear transformations. इस collection पे हम अब इस तरह के दो operations define करेंगे. This is the addition and this is the scalar multiplication. And we define the addition by t1 plus t2 of v is equal to t1v plus t2v. And define the scalar multiplication as alpha times t of v is alpha t of v. ठीक है. Now under these two operations, this is the internal composition and this is the external composition, and we also call this as the addition of the vectors, and this is also known as a scalar multiplication, and this alpha is from f respectively. Actually we should here write for all alpha belonging to f and v belonging to v. Now under these two operations, which are the binary operations, and this is the internal composition and this is the external composition, or we can call this as the addition of the vectors in L of VW, and this is the scalar multiplication of L of VW over the field F. Then under these two binary compositions, this L of VW forms a vector space. तो अब इस चीज को वेक्टर स्पेस दिखाने के लिए हमें वो सारी ऑपरेशंस प्रूव करने हैं that it is an additive abelian group under the addition defined in this way, and then it satisfies those properties of under scalar multiplication which are distributive and the other properties. ठीक है. So now let's try to do the same thing. So first we will show that this internal composition, under the internal composition, this L of VW forms an additive abelian group. So now let's write down the proof. इसमें लिखना बहुत है but है आसान. So what we have to do to show L of VW is a vector space. Is a vector space under the operations defined by T1 plus T2 of V. This is equal to T1 of V plus T2 of V and alpha T of V is equal to alpha T of V. Now,
So please एक मिनट बैक स्लाइड कर
ये
सकते
थोड़ा
हैं?
सर एक मिनट सर पहला वाला पेज देख
अस्सलाम वालेकुम सर।
हाँ वालेकुम अस्सलाम.
सर अगर आप मतलब ऊपर से ये प्रूफ दिए बहुत टाइम लेगा, फिर आप नोट्स सेंड करेंगे, हम खुद देख लेंगे।
मैंने आपको नोट सेंड किए हैं ना, ये इतना मतलब मैंने उस पे भी वो नहीं लिखा है इसका प्रूफ. अगर आप खुद करेंगे तो वो बहुत अच्छी बात है. फिर नोट्स तो मैंने आपको यहाँ तक भेजे, आपने वहाँ पे देखा होगा, वहाँ आपको मैंने नोट्स भेजे यहाँ तक.
यस सर
नहीं, मुझे लगता है मैंने आपको पेज नंबर 11 तक नोट्स भेजे थे, लेकिन मैंने लिखे हैं पेज नंबर 12 तक. लेकिन इस थ्योरम का मैंने स्टेटमेंट लिखा है और मैंने नोट्स पे इसका प्रूफ भी नहीं लिखा है. अगर आप खुद करेंगे तो अच्छी बात है, अगर आप वरना हमें ये सारा यहाँ पे लिखना पड़ेगा।
सर हम खुद लिख रहे हैं।
हाँ चलो बहुत अच्छी बात है। चलो फिर मैं थोड़ा सा आपको ऐसे ही बताऊंगा आपको करना क्या है। तो पहले हमें दिखाना होगा दिस इज क्लोज्ड। तो क्लोज्ड दिखाने के लिए हमने प्रीवियस ये थ्योरम की है, द ऑपरेशन इज क्लोज्ड, तो उसके लिए हमने दिखाया है T1 plus T2 इज अ लीनियर ट्रांसफॉर्मेशन। तो पहला स्टेप इसमें यही होगा। सो दिस theorem says that these two operations are well defined and they make this L of VW closed under these two operations। क्योंकि पहले हमें दिखाना होगा T1 plus T2 is also inside L of VW, तो वो हमने यहाँ पे दिखाया। और उसके बाद हमने सेकंड पार्ट दिखाया alpha times T is also a linear transformation, so therefore L of VW is closed under these two operations. So therefore under this addition and under this multiplication, this L of VW is a closed set. Then you have to show that it is commutative, and that you can easily do. You will write T1 plus T2 of V is equal to this thing. Then this can be written as T2V plus T1V, because now these two, now T1V and T2V, these are the elements of W. And W is a vector space, so it is a commutative abelian. So it is an additive abelian group. So T1
सर
plus
नहीं
T,
अच्छे से दिखाइए सर,
हाँ
सर अच्छे से दिखाइए, खुद नहीं आएगा।
चलो ठीक है, फिर करेंगे ये सारा।
यस सर।
Yes, sir.
चलो ठीक है, करेंगे one by one. The first step is to show L of VW is closed. हमें पहले ही दिखाना होगा क्लोज्ड। और इस क्लोज्ड को दिखाने के लिए पहले हमारे जहन में होना चाहिए हमें क्लोज्ड दिखाने के लिए क्या करना होगा। सो नाउ लेट्स राइट डाउन इट हियर। तो हमें क्लोज्ड दिखाने के लिए क्या करना होगा, वी विल चूज T1 एंड T2 बिलोंग टू L ऑफ VW। तो हम दो लीनियर ट्रांसफॉर्मेशन चूज करेंगे और हम प्रूव करेंगे इनका सम भी होगा लीनियर ट्रांसफॉर्मेशन। तो हमें ये दिखाना होगा टू शो T1 प्लस T2 बिलोंग्स टू L ऑफ VW। तो इसको इस दिखाने के लिए हमें प्रूव करना होगा दिस T1 प्लस T2 इज अ लीनियर ट्रांसफॉर्मेशन। तो अब वो हम करेंगे यहाँ पे। सो नाउ लेट T1 T2 belong to L of VW, then we show T1 plus T2 belongs to L of VW। तो इस चीज को आप रखिएगा साइड में। नाउ हमें दिखाना ये लीनियर ट्रांसफॉर्मेशन है। नाउ लेट अल्फा बिलोंग टू V and not V, but let alpha belong to F and V belong to V। Then T1 plus T2 of, हमें इस तरह से दो चूज करने, लेट यू वी एंड यू बिलोंग टू वी, अल्फा u plus v। नाउ दिस इज इक्वल टू व्हाट इज इक्वल टू नाउ, ये हमने किया है प्रीवियस थ्योरम में, ठीक है। तो इसको हम डायरेक्टली अब यहाँ पे लिखेंगे दिस अल्फा टाइम्स T1 प्लस T2 ऑफ u प्लस T1 प्लस T2 ऑफ v। और इसको हम यहाँ पे लिखेंगे बाय प्रीवियस थ्योरम। So thus T1 plus T2 is a linear transformation। तो इस तरह से हमने प्रूव किया अगर हमारे पास दो लीनियर ट्रांसफॉर्मेशन है T1 and T2, then their sum is again a linear transformation, that is L of VW is closed under vector addition। वेक्टर एडिशन कहेंगे या इंटरनल कंपोजिशन कहेंगे। So to show that this closed, अब हमें दिखाना है this also closed under the scalar multiplication। Now again again alpha times T of V. Now this is equal to alpha times T of V, and this belongs to prove करना होगा, this is linear transform. Now again alpha times T of something like AU plus V. Now this is equal to by definition, ये असल में हमने ये भी प्रूव किया है प्रीवियस थ्योरम में, तो इसको यहाँ पे डायरेक्टली हम फिर से लिख सकते हैं. This is alpha times not alpha times but A times, again by the previous theorem, this A times alpha T of U plus alpha T of V, again by previous theorem. किया ना हमने प्रीवियस थ्योरम में यही प्रूव, अल्फा टाइम्स अल्फा टी ऑफ ए यू प्लस वी, हमने ये प्रूव किया दिस इक्वल ए, ये हमने प्रूव किया दिस इक्वल ए टाइम्स अल्फा टी ऑफ यू प्लस अल्फा टी ऑफ वी बाय प्रीवियस थ्योरम. सो thus L of VW is closed under scalar multiplication. So the first property is done. Now the next property is we will show that this is commutative. वैसे commutative लास्ट में दिखाते हैं, तो हम पहले भी दिखा सकते हैं क्योंकि इसमें कोई मसला नहीं है, हमें कुछ भी करना है. So now first let's show it is commutative, then associative. Now let T1, T2 belongs to L of VW. Then T1 plus T2 हमें दिखाना होगा is equal to T2 plus T1. Now T1 plus T2 of V, by definition, this is equal to T1 of V plus T2 of V. अब यहाँ पे हमें use करना होगा because now this T1 of V is in W because T1 is a linear transformation from V into W. तो इस हिसाब से T1 of V is an element of W and T2 of V is also an element of W, and W is a vector space. And once W is a vector space and these are two elements of a vector space, so therefore we can write them as, so therefore they will satisfy the commutativity. So therefore we can write this is T2 of V plus, और ये कहाँ से आया हमें, T1 of plus T2 is equal to T2 plus T1, ये हमने use किया because W is a vector space and these two are the elements of W. Now by definition, again by definition of this T1 plus T2, by definition of the vector addition, this is equal to T2 plus T1 of V. तो इस तरह से हमने प्रूव किया T1 plus T2 of V is equal to T2 plus T1 of V. हाँ हाँ बताइए.
हेलो सर,
हाँ
जो स्टेप है ना लास्ट में T1 plus T2,
हाँ
ये दोनों T1 into V T plus into V आएगा, दोनों में V आएगा.
हाँ V है ना दोनों में.
यस सर.
तो यहाँ पे देखिए हमें V इसलिए लिए, पहले में हमने V नहीं लिया था क्योंकि पहले में हमें दिखाना था दिस इज अ क्लोज्ड सेट, L of VW is closed. तो इसको क्लोज्ड दिखाने के लिए क्या करना, प्रूव करना था कि अगर हम इसमें दो लीनियर ट्रांसफॉर्मेशंस लेंगे उनका सम भी है लीनियर ट्रांसफॉर्मेशन, तो उसके लिए हमने लिया अल्फा यू प्लस वी. उसके बाद हमें प्रूव करना है अल्फा टी इज आल्सो अ लीनियर ट्रांसफॉर्मेशन, तो हमने इसको वो जिस तरह से लीनियर ट्रांसफॉर्मेशन की डेफिनेशन है, a mapping is a linear transformation if it satisfies T of alpha x plus y is equal to alpha T of x plus T of y. तो क्लोजर दिखाने के लिए हमें दो लेने थे, लेकिन यहाँ पे हमें लीनियर ट्रांसफॉर्मेशन नहीं दिखाना है, अब हमें सिर्फ दिखाना है T1 plus T2 is same as T2 plus T1. So actually this means that जो T1 plus T2 whatever T1 plus T2 does to V, the same action is done by T2 plus T1 on the same on the set vector V. And this is for all V belonging to V. So this implies this implies addition is commutative. This implies vector addition is commutative. तो इसके बाद हमें दिखाना है अब एसोसिएटिव, बट नाउ वी आर हैविंग लेस देन अ मिनट. तो अगर आपको इसको वो स्क्रीनशॉट लेना है तो आप लीजिए. नाउ वी विल